Hi, everyone, and welcome to Astro at Home, presented by Discover the Universe. Usually, we teach your teachers, but while we're all learning from home, we're happy to come into your homes with you and your parents to teach you a bit about astronomy. Before I present our speaker for today, I would like to remind you guys of some of the rules for the chat. We love getting your questions, so send us as many as you can think of, and we will send them to our speaker today to answer. But we ask that you stay respectful and not spam. And if you break those two rules, then we'll put you in a timeout, which means you won't be able to. Our speaker today, Amanda Greene. She is a science teacher coming out of Alberta, and she's super excited to talk to you guys today about space gardens. And so welcome, Amanda.
Hi, well, thank you for having me.
Our pleasure. You can just jump right in and we'll get started. I've got the kids sending us their space emojis in the chat.
Oh, I can't wait to hear what they have to say and what your questions are. So welcome. Here we are with I guess our new way of learning, our online school. So I'm just going to bring a little bit of what I like to talk about in my classroom to you guys. So my name's Amanda Greene, and I am a French immersion and English science teacher and technology and math in Beaumont, Alberta, so just outside of Edmonton. And my favorite subject, my favorite thing to talk about is space. So I'm going to share with you some of the things that I know about gardening in space specifically. So we have these goals as humans to get aboard these rockets, go off into space, everything from the moon landing, the International Space Station and beyond. And one of the things that we're going to need to be able to live in space a little bit more than these small trips that we do is to be able to grow our own food. So we've already grown food in space. You can see Scott Kelly and one of the other astronauts aboard the International Space Station, and they were the first people to grow lettuce in space that they could eat. Now, they don't get a lot of fresh food on the space station. When ships come up, they will bring supplies of fruits and vegetables and things, but to grow your own food in space is pretty incredible. They've grown types of bok choy, I believe, and different grasses for different scientific experiments. And one of the coolest parts is they were growing flowers in space. And so these were all different scientific experiments to see that, first of all, could we grow things in microgravity? Now, this is one of the projects that I love the most. It's called Tomato Sphere, and I've been doing this with my students for years. It's from a group called Let's Talk Science. And what they do is they take seeds and they'll have two packages, and they'll give you one or give you both. And one of them, the seeds have come from this big package that you can see David Saint-Jacques is holding. And those seeds have actually gone up to the International Space Station, have flown around the Earth hundreds of times and come back down. And the experiment is that you're going to take those space seeds and you're going to take Earth seeds, but you don't know which are which. And you're going to plant them and germinate them at home, and you're going to see which ones will grow. So I think this next picture shows you the packages of seeds. David Saint-Jacques is a Canadian Space Agency astronaut, one of our 4 active astronauts, and he got to fly in space last year. And through Let's Talk Science and Tomato Sphere, I was able to talk to him from the International Space Station, and it was pretty incredible. But I love that we have this opportunity. So teachers, if you're listening, go to that website, sign up, and get seeds that you can. I always save my seeds, and I plant them in September anyways. And if we have to do it virtually online, you can. It's a really good experiment. I'm thinking they might even open it up to parents and families to try if we continue with online school. So one thing that we talk about as Canadians in space, which I'm super proud that we are such a big part of all of the different space initiatives going around the world, but the coolest thing that I am super proud of is the Lunar Gateway. Now, this was proposed initially by NASA, but Canada was the first country to sign on. So what we've agreed to do is build the Canadarm3. So Canadarm1 was on the space shuttle, helped us build the International Space Station. Canadarm2 is on the International Space Station right now with the mobile hand we call Dexter, and the Canadarm3 will be on the Lunar Gateway. The Lunar Gateway is going to start being built in the next few years, and it's going to be like an International Space Station, but it goes around the moon. And then eventually we're going to use that and maybe going on to the moon to get us ready to go to Mars. And so how are we going to do that? Well, if we need to bring food to space and all the supplies that are required, it's really heavy and it costs a lot of money to send rocket ships to Mars or the moon or into space in general. And so if we can use what's already on a planet, it'll make that faster and safer. And so one of the things that we can do is test, can we actually grow plants in Martian soil? So if you didn't know that, we're actually already trying this as we speak. So this is a gentleman from the Womenling Institute, and they use something called regolith. I don't know if you can see in the small picture here. And regolith is basically ground up lava rock. So this is like a rock like you'd find inside of a volcano, maybe in Hawaii. And they grind it up and they make it into something called regolith. And I'm going to tell you a little bit more about it later, but they basically make simulated Mars soil, not real Mars soil. It would cost millions of dollars just for a little container like this of Mars soil. We don't have anything like that yet. And they're testing and they're seeing, hey, can this actually happen? And so you can see sort of a closer picture here. We were watching a spacewalk in my classroom, and we have a couple different kinds of stimulants in my school that we've been able to buy and use. One is a Martian simulant, and the other is a lunar simulant. And it's just, simulant means to simulate, to be like the soil that would be used on another place. So it's the closest version that we can figure out to use. So they take up ground up lava rock, and that's like the Mars simulant. And then more like the ashes is more like the lunar simulant. It's got a little less iron, it's less red. And that's when you see the red planet, that's because of iron. And we call this regolith because it's not soil. Soil has decomposed organic matter in it. Soil has bacteria and living things. Soil has nutrients, and this regolith does not. And so in my classroom, what we did is we took our tomato plants from Tomatosphere and we planted some in earth soil, some in Martian regolith, some in lunar regolith. We added different fertilizers. We even mixed in some earth soil with it to see how it would grow. So I want you guys to know the difference between soil, which has all of these nutrients, and regolith, which is just basic minerals. That's what's on Mars and that's what's on the moon. So now we have to figure out, well, are we able to grow in these conditions? And the answer is maybe. If you look here, these are some pictures from my classroom. And in the first year, we found that some fertilizers did work. We have to remember, we have to bring those fertilizers all the way to Mars. So another thing that they do is they think about, well, what do we have as natural fertilizer? Like human waste. I'm gonna just stick to that term, human waste. We can take it and we can use it to try and help grow different plants and nutrify the soil. Now, the problem is that it needs to decompose a little bit more. And so we have to think about that and we have to test it. And that's why scientists all over the world are trying out different methods, and just like we've done in my classroom. And you can kind of see in the picture to the right that we've used different portions of earth soil mixed in with our regolith or different fertilizers. And that really, you need quite a bit to make it grow, because soil is this awesome living thing. And then you can see at the bottom there some of the yummy tomatoes that we got. So that was a really fun thing to be able to grow. And hopefully everybody at home is starting to plant things at springtime so that you'll have vegetables to take care of and food to have in your houses. One of the coolest things was being able to have an astronaut come to my class. And this is my friend, Dr. Robert Thirsk. And he was able to come to our class because we got to talk to David St. Jacques Lab in space. And when he came in, he got to come and see our gardens. And you can see the Mars plants, how thick and little they're looking, and how they didn't do very well. And so it brought to an interesting question: is using Mars soil viable? Can we bring enough fertilizer? Are we able to go to space? And it's not there yet, but we're working on it. Lots of people working on different things. It's not just the rocket ship. So what I think is the most important part, since we're stuck at home, is to be able to do some of this science at home. So I want you guys to see, is your soil mostly regolith, or is there a lot of those other components of soil? And so this is something I think we do in grade 7, and I can't remember if it's grade 4 or grade 3, but it's a way that you can test to see what your soil is made of. Now, soil is made of different kinds of components. There's sand, silt, and clay. Sand are big pieces, silt are medium, clay are smaller. And good soil has all 3 of those and organic material. So what you're gonna do, and you don't have to do this right now, but you're gonna go find yourself a jar. So I use a mason jar. And you're going to go and dig up some dirt. Don't dig up your parents' flowers, okay? But go get some dirt, put it in there. And if you want to compare, try getting some sand from somewhere, I don't know. and you're going to fill the jar up with water. All the way up. And put on the lid. Maybe ask a grown-up to help you make sure it's on tight. All right, make sure it's on super tight, and you're going to give it a good shake. Shake, 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 shake. Shake it up and break up all the material, and then you're going to let it sit. Now, right now, you can see here, if I hold it up to the camera, it's really dark and cloudy and muddy. I'm going to let this sit, and maybe by the end of the talk, you can see what's happening. If you look at the picture here, I did this with my students in a little tube. So if you have a little plastic tube, it's even better. The taller the container, the better. And you can see that this was some beautiful earth soil. On the bottom, there was sand. And then the middle layer, there's some silt. On the top is some clay. On the very, very top floating is actually all the organic matter. But if you were to do the same thing with Martian regolith, it would all sink to the bottom and it would be mostly silt and clay because Martian soil is very, very, very fine. But there wouldn't be that organic matter floating on top. So it wouldn't be nice, healthy soil. When you combine sand, silt, and clay together, we call that loam. And loam is really, really healthy soil. So if you guys try this out, I want you to see if you have a nice organic layer on top and how much of sand, silt, and clay you have on the bottom. It should be a pretty even mix if you want to have really healthy, good soil. All right, and there's a link at the bottom there that'll be posted below that you can click on if you need some more instructions for that. So the next thing that we like to do in our evolution of learning about space gardens is we thought about, okay, can we grow in this soil? Well, only if we make sure that we're adding fertilizers, whether that be human waste or actual earth soil or chemical fertilizers. The next option is maybe going soilless and using something called hydroponic gardens. Hydroponic gardens, you can see a picture, these are all my students. They built these gardens and there's no dirt, no soil at all. The hydroponic gardens use tubes or containers and tubs, little pebbles to hold the seeds, and water that you have to add fertilizer to. So we've actually discovered that hydroponics uses way less water than planting in soil, but you do need to bring a lot of chemical fertilizers. So is this what we're going to do on Mars or in space? Maybe. They already do that in sea cans in the Antarctic and the Arctic. In northern communities, they have these big boxes that kind of go on the back of trains, and they put and they grow indoor gardens. And so hydroponics might be the next thing that we do and the next way to grow things in space. Now, I don't know if you can see it, but you can see some of the lights shining on our plants are magenta or kind of a pink color. And this is maybe for some of the older kids, but when we look at light, white light is made out of 3 different colors. We've got green, red, and blue. It's not like paint, there's not yellow there. But plants, they don't need the green light. They reflect it off of them. And so to save energy, which is kind of what we're doing to try to get to Mars, we don't use that green light. And so magenta lights are just that blue and red. And so they use less energy. The plants can still grow nice and green. And that's sort of kind of some fun little light and optic science, I think. Depending on what grade you're in, you might have learned that already. Another cool thing that we've been learning about are sprouting seeds. And so if you see the picture of the lady with all those sprouts, those are bean sprouts. You can get alfalfa sprouts, and there's lentils and even little baby basil sprouts. That's a really great way to grow food. And I think that's another thing that they're going to do when we go to space. So another activity that you can try at home is to grow your own sprouts or your own little greenhouse. So what we do is if you take these little containers that your berries come in from the store, make sure they've all been washed and are safe. You can take these and you can put either a piece of paper towel on the bottom or even a little layer of dirt. And then you can sprinkle some seeds on top, cover them with water, close it up and put it in a sunny spot, and you've just made yourself a little tiny greenhouse. And this is kind of a way that we would start growing some plants if we were going to see, because it can produce nice, healthy, fresh greens. And then because it's closed, it lets the light in and the heat in, but it doesn't let it escape. And that's why it's called a greenhouse and the greenhouse effect. So another little at-home thing that you guys can try. If you don't have any seeds, if you look online, West Coast Seeds is a really great Canadian company, and they have lots of different sprouting seeds that you can buy, and you can try that at home. Awesome. Now, I think before I move on to this, I wanted to show you guys my tomato plant here. And we're going to talk about this plant a little bit more. And these are one of the ones that I got to bring home, sort of in the corner there. I might actually wait till we go full screen to show this to you, but this is one of our tomato plants. And I think it's important that we all learn how to grow things at home and also in space. It helps keep us all healthy and eating nice fresh foods. That's my little tomato plant. Now, this is something I think is really exciting. After we've learned all about space gardening, to kind of learn about something really neat that's happened here in Canada. We got to name a star an exoplanet. And I actually got to help with it, which was really cool. So Canada had this Name an Exoplanet contest, and it was from the International Astronomical Union. What they did is they said, hey, we've discovered, I don't know how many, a couple hundred stars and little planets that go around them. That's called an exoplanet. And we want to give countries all across the world the opportunity to name them. So Canada was given one star with its exoplanet around it. And they had a contest and they said, hey, name it. So I sent in an entry and I was thinking to myself, what is Canadian? What do I want to have up in the stars forever? And I thought to myself, well, you know, if we're going to be learning about the stars and looking out towards these stars, I also want to think about where we've been. And our country started with our First Nations people who have been here well before any of the European settlers. And they were looking at the exact same stars and the exact same constellations and building their sense of community and their stories and their legends and their whole culture around those exact same stars that we're looking at right now. And will those be the same stars and constellations that people in the future will be looking at? Yes, for the most part. So I thought it would be really important to make sure to use a First Nations name. And so I picked Cree. I'm from Alberta, and we have a lot of Cree people here. And I thought, well, okay, that's half of it. Now what else is important to me? And family is the most important thing to me. I know we're all stuck at home with our families right now, but they're the best part. And if I had to be home with anyone, being home with my children is pretty, well, most of the time it's pretty okay. And so I decided that I was going to name them Nigawe and Awasis, which means mother and child. Now, I am not a First Nations person, and so I needed an expert to help me out. So you can see in this picture, this is Mr. Wilfred Buck, and he's from the Manitoba First Nations. And he was able to look at my submissions and let me know if I had my spelling right and if I chose the right words. And so it was a pleasure to work with him. So you can see this picture here, how you say it. So it's Nigawe and Awasis. Nigawe means mother and Awasis means child. And I picked that because I thought that the star should be Nigawe, the mother, and the child is rotating around it, always looking for the mother and following them. So I thought that was kind of special. And the neat thing is oh yeah, it's in the constellation called Boots, which you can kind of find in the night sky. If you go when all of this is over and we can all go outside again and go to our science centers and our universities, you can look at it through a telescope, and just at the point of the Boots constellation, it's like one of the top of the screen that kind of looks like an ice cream cone on its side. You'll see where they can be found. You can't see them with the naked eye though. You have to telescope. I haven't even seen them yet. The neat thing about Oasis is that it is a super giant, like a gas giant, like Jupiter. And so they think it's this big, beautiful planet circulating around Nigawe. And what we were told is if in the future they discover other exoplanets around Nigawe, that they'll actually name them other Cree family names. So maybe if Oasis is child, maybe they'll do grandmother or uncle or aunt or friend or one of those words. So I thought that was kind of a really great way that we can all come together as a country from our past all the way to our present and into our future. And so, yeah, that was pretty exciting. Before we head to question and answer time, there's one other thing that I have to mention, especially if we're all at home and we're looking for fun things to do, especially if you love space like I do. The Canadian Space Agency has a really great program called Junior Astronaut. And although they've suspended the way that they were doing it before you could apply to go to space camp, I don't know what's happening with that now. But if you go to their website, they have all kinds of online games and activities. They have an egg drop challenge. So if you tell your parents, oh, this science lady online told me I can throw an egg out my window, kind of. An egg drop challenge is where you're going to design a Martian or a lunar lander, and you have to take all the things in your recycling bag and try to protect an egg. And then you and your brothers and sisters can all build one and have a competition. And then with parent help, I know I'm going to do this with my kids, and we will be dropping them from our deck down onto the patio, and we're going to see which ones survive. So there's all kinds of challenges like that. The lunar lander one's pretty fun. There's physical ones, there's ones about food and nutrition. So if you are looking for something to do, excellent online resources. And you can learn a little bit more about the Canadian Space Agency, about our astronaut program, and all kinds of good educational stuff on there. All right, so I think we're going to open this part up to question and answer, and you're welcome to ask me anything you want about space. I'm not an expert, I'm not an astronaut, I'm just a nerdy little teacher. So you can, we'll get to that part, and I'll do my best to answer them. And if I can't, I will try to find some answers if you're looking for activities, or if you're just curious and want to know how things are going. This is a pretty good time for that. So here we go. All right. Okay, so how are space gardens affected by zero gravity? Ooh, that's a really good question. So part of the Tomato Sphere project is bringing seeds. I kind of rushed through it because I was worried about time, sorry. Bringing seeds up to the International Space Station, letting them circulate, coming back down and testing how seeds are changed by microgravity. But the actual space gardens, when they're in space, if you think about it, you can't have like a pot and a plant in it because it'll all float away. And so space gardens, from what I understand, are kind of these little enclosed structures with kind of like a piece of foam inside, and then they take a syringe and they inject it in into the foam so that it can feed the roots, because otherwise the water would just float away. There's been studies watching, well, do roots still grow down or do they grow up? Do plants go out? Obviously, the plants will go towards the light, so that stays the same. But the root growth, I think, is a little bit, I'm not 100% sure, but a little bit affected by microgravity in that regard. Okay, what are the questions we have? Is it possible to plant plants on Mars? Well, maybe. So far, the studies that I've seen, mostly out of Holland from the Wageningen Institute, sorry, it's a really hard word to say, they've been finding, they were studying different fertilizers, manure, and now they're actually taking urine and they're processing it, and they're using that to fertilize their plants in Martian simulant soil, and so far it's working. So yeah, you can recycle urine for drinking water, you can use urine and the nutrients within it to feed plants because it's full of nitrogen. So it is, we think it's possible. We haven't been to Mars yet, only robots live on Mars. So one day, though, we're hoping to bring our plants there and do some more studies and see if our simulated soil is close to the actual Martian soil. What grade do you teach? Oh my goodness, I guess I should have said that in the beginning, don't I? I teach mostly grade 9 science, but I also teach grade 7 and grade 8. And I have taught grade 4 before, and I've taught high school before, but mostly junior high, so middle school science. What class is the star? I don't know. I don't think it's a very massive star because it's not visible, although it could be far away. I don't know. That's a very good question. Is it possible to plant a carnivorous plant in space? Okay. Do we know what a carnivorous plant is? So if you ever get to go to a local like botanical garden, or even around Halloween, usually in like Home Depot or Canadian Tire, they'll have carnivorous plants. So they're like the Venus flytrap, and it stays open like this, and it's bright colors and has nectar. When an insect comes along and stimulates the plant, it'll close shut. Or there's a pitcher plant, which is like, it looks like a big pitcher, like a little cup, and it's got a little cover on it, and an insect will come along and fall inside of it and get trapped, and the plant can actually decompose and eat the insect. Can we plant those in space? Could. I don't think we would, though, because the plants that we're going to bring with us to space are going to be things that have high nutrient density. So that's why they like tomatoes, because the seeds are really little, and then you get this big, beautiful plant here. Now I can show more of it to you. And it produces flowers and fruit and all these wonderful things. Just on a side note, I don't know if you can see the little flowers on the top of my plant here, but I have to actually go and be the bee. So I tickle my flowers and I help pollinate them because we're not going to have pollinators in space. We're not bringing bees with us to space. I think that would be problematic. And so that's part of it, is that we have to do all of that, but I don't think we would bring carnivores. Very good question, you guys. These are awesome. Okay. How big exactly is Oasis? Oh, I think it's about the same size as Jupiter. To give you a kind of perspective how big Jupiter is, you can take all the planets, Earth, Mars, Saturn, all of them, and fit them inside Jupiter. It's a gas giant. So if you want to know what the difference between those are, so our first 4 planets, those are all what we call terrestrial planets, or rocky planets, all the way up to Earth and Mars. And then we have an asteroid belt, and then way farther out, all of our gas giants, so the last 4 planets, and they're a lot bigger, and we think that they're all made up of different gases. Is it possible to plant on Venus? Okay, so Venus is, so how I remember all the planets, I always say, my very eager mother just served us nachos. You don't count Pluto. Pluto's not a planet. I know we love Pluto. Pluto has a little heart. Pluto's lovely. My aunt and I fight about this all the time. Pluto's not a planet. So the first 4 are our terrestrial. The last 4 are our Jovian, our gas giants. So my very eager mother. So Mercury, Venus, Earth, Mars. Venus is the second planet. It's quite a bit closer to the sun. It gets really hot, really cold. And so it is not possible to go there or live there. We're not even considering it. The reason why we're going to Mars is because it's further out. It's a lot colder, but we think it's the closest viable place that we can explore. I don't think we could plant anything on Venus. Can we plant anything on the moon? Well, that's going to be part of what we're doing. So if we want to get to Mars, and they're hoping that like late 2030s, early 2040s, which I think is, or is it 2050s? Anyways, in my lifetime, they're hoping to get to Mars. And in order to get there, we have to take baby steps. So right now we're working on rockets. NASA has the SLS, the Space Launch System, and the Orion capsule. SpaceX is making their Dragons and their Falcon rockets and their space, all kinds of rockets. And so in order to get to all those things, we need to be able to take our baby steps. And so the first step is going to be build this lunar gateway around the moon. Second step is to actually make a smaller colony or a semi-permanent colony on the moon. And the reason why they think that'll be a way to see if we're ready to go to Mars is because the moon's close enough. It's only 3 or 4 days journey to get back to Earth, which doesn't seem that long, but it's really far. But Mars is even farther. And so we're hoping that we can make a small test colony and test everything out and grow vegetables and food and things on the moon. Okay, next question. What would we eat in space? And something about livestock. Okay, so if you want to be an astronaut when you grow up, and it's going to be all of you guys going to the moon and Mars, and not me, I'm not going, I'm staying here. You'll call me from there, though, and we'll talk. Although from Mars, it takes something like 20 minutes for the message to get there, 20 minutes to get back. But if you want to be an astronaut and you want to go to the moon or Mars, you're going to have to be a vegan. So vegan means no meat, no eggs, no dairy. If you look, and this is kind of like at our food pyramid, at the top of our food chain, we have our carnivores. At the bottom, we have all of our producers, all of our plants, and it moves up those levels. The amount of energy that you can get from planting crops, whether it be beans or lentils or tomatoes or lettuce, the amount of energy you need to feed a cow or a chicken for their lifetime, and then for us to be able to consume it, is not in balance. It's not worth it. So if we're doing the math of what we're going to bring with us to space, it is a lot more sustainable and economical to just bring seeds and all the things we need to grow gardens and not bring animals. And so that means no pets either. We're not going to be having, they might maybe bring some smaller animals, I'm thinking, for like doing pests like that kind of thing for testing, but I don't think we're going to have any kind of meat or eggs or fish or anything like that on Mars. So you're going to have to be a vegetarian or a vegan. Okay. What's my favorite planet? Oh, I love that question. Well, Problem is I have a couple answers. My favorite planet is Earth. My favorite planet is this one. It's perfect. It's in the Goldilocks zone. It's not too hot. It's not too cold. It has an atmosphere. It has water. It has every person I've ever loved. It has every person ever on it, other than the few people in the International Space Station. Our planet is amazing and it's beautiful. And I think one of the things that I think is the most important thing is that I don't think we should be going to Mars or the moon or anywhere else until we can take care of this planet first. But the cool thing is that space is so exciting and people are thinking, if I'm going to go to Mars, I'm going to need to make sure that all of the things I build are the most energy efficient lights and the most energy efficient ways of growing plants that save water and use less resources. And so scientists are getting so excited to help us make all these technologies to help life here on Earth or on Mars, but it's also going to help life here on Earth. So I always say Earth is my favorite planet. We need to take care of it. If I had to go anywhere else, or if I had a second favorite planet, it would be Mars, because it's just so exciting to see if we as humans are capable of going there and doing these great things. Okay, next question. If we go to Mars, will we come back? Have you ever been to space? Oh my goodness. Okay, so going to Mars, at this point, only robots have been to Mars, all the different rovers that are there right now. And there's another one that's going to be launching. It was supposed to be launching in 2020. It might be delayed to 2021. And so right now we don't have humans on Mars, but we will be going there. And will we come back? It used to be that people thought, no, if you go to Mars, it's a one-way ticket. You get there, you live there, that's it. But now we're realizing that that's a little bit harsh. And so we're developing technology and taking a little bit more time, being a little more ambitious, that we can be able to leave our planet, go to Mars, and come back. Now that means that there'll be shorter flights at first, or shorter durations. But I think some people are ambitious that one day we'd be able to take the carbon out of the atmosphere on Mars, create a type of fuel that could help send us back, and then we can stay for longer. But wouldn't it be great if that same technology helps take all the carbon out of the air here? I think that's pretty great. Would I go to space, or have I ever been? I've never been. No, I'm just a teacher who loves space. I would love to have gone, or love to go. Right now, they're developing what you're going to call space tourism. So Virgin Galactic is one of the examples, where you can pay probably as much as it costs to buy a car to go to space and come back. It's not there yet, but it's supposed to be becoming more and more popular. I would totally do that. I would even like if they were just like, hey, we're doing a teacher in space program, which they did do once. You want to go to the moon? I'm like, yeah, you know what? I would totally go to the moon. But I don't know if I would go to Mars. I don't think it's quite, the technology is not there yet. But maybe if I were younger and maybe if the technology were further advanced, maybe I would go. But for now, I really like Earth. How long does it take to get to the moon? Okay, the numbers part of all the space travel is not my forte. I believe it takes something like 4 days to a week to get there, and then the same back. I'm trying to think during the Apollo missions if it took longer, because you have to kind of go around the Earth and then around the moon, and kind of this figure 8 configuration is how they get there. I'm not 100% sure on those dates, so don't quote me on that. You might have to look it up, but yeah, it takes days to a week to get to the moon and months to get to Mars. I think 4 months. All right, what's my favorite constellation? You know what I love about constellations is that constellations, we sit from where we sit on Earth, we look up at the stars and you can kind of see most of the same constellations depending on where you are in the world from another spot. So the constellations that I'm looking at here in Alberta, maybe those are the same ones you're looking at, but maybe just slightly different from in Ontario or Quebec or somewhere else in the world. And that we as humans, when we look at these stars, we see a two-dimensional shape. So the Boots constellation looks like a little ice cream cone, and the Big Dipper looks like a spoon, or some people think of a Great Bear and the Little Bear. And I love that we as humans can look up at the stars and see different pictures and make up different stories or beliefs or thoughts about, hey, I wonder what that image looks like and what does that mean to me. I have to say that my favorite one is the Boots constellation because that's where our star is. But yeah, it's just neat that everybody on Earth has these dreams and these ambitions and these thoughts about stars that actually, if you looked at them outside or from a different point of view, would look totally different. If you're outside our galaxy, our stars would look completely different. The sky would be nothing like it is here. That's awesome. You guys are asking such good questions. Did I miss any? How big is my plant? Okay, I'm going to see if I can back up a little bit, show you my plant. So in my classroom, you can see it kind of comes from here all the way to there. It's hard to show the whole thing on the screen. This plant, we plant them in September. Now, Tomatosphere normally would send you your seeds this time of year, but I like to save my seeds till September, and I grow tomato plants in my classroom all year long. And my whole back window is covered in these plants. I probably had, a dozen of them growing. Some of the years I have 20 or 30 of them growing. I have a friend, Mrs. Arsenault, who teaches in Edmonton, and her class looks like a jungle. She has so many of these tomato plants growing. But the best thing about having plants in your classroom is that it smells good, they clean the air, and it's something to take care of. It's a conversation piece. It gives the kids some responsibility. So when we were told that we all had to go and stay home and stay safe with our families and do online schooling, I had all these plants. I don't keep plants in my house. Lots of plants at school, but no plants at my house. And so I took one home, but luckily all the other teachers in my school all took plants home. And earlier on in the year, when the tomatoes were little, we sent plants home with kids. And now kids and teachers all send me pictures of their tomato plants, and I get to see how they're doing in other people's houses. And I love the idea that even though we're all in separate houses, that we're all still connected by sharing our stories and what we're doing and growing plants at home. So I hope you guys all can grow some plants at home and think about, how would this grow on Mars, or could I grow this on the moon? That's awesome.
Thanks, Amanda. We are running out of time for questions, so I'm going to have to cut it there. But there was some really great participation in the chat. If you guys enjoyed Amanda's talk today, can you send us some cool plant emojis in the chat so that we can see how much you enjoyed it and give us a thumbs up? Thank you so much, Amanda, for joining us today. I think that was an excellent talk. The kids really seemed to enjoy it.
Oh, good. I'm glad. I get really excited about space, so I start talking really fast. So I'm sorry the beginning was a little rushed, but it's really great. And I'll have a look at the chat later, and if there's any questions I can keep answering there, I will. So thank you everyone for participating. This was great.
All right. Okay, so thanks everybody who joined us today. Just as a reminder, in a couple of seconds, I'm going to update the description box below to include links that Amanda has shared with us all to go explore some different topics relating to space gardens, and some of the experiments that she was suggesting will also be in there for you, so you can go check those out as well. And we also have a bunch of other resources for science education while you're learning at home. So if there's something else in science that you're interested in other than astronomy, you can go check those out too. If you haven't done it already, give us a thumbs up on the video. Click the subscribe button and the notification bell so that you know when we're online again tomorrow. Tomorrow we'll be welcoming back Mary Beth Lachak from Hawaii at the Canada-France-Hawaii Telescope. I'm not totally sure what she's talking about tomorrow, but I'm positive it'll be excellent. And so spread the word. If you want to join us again tomorrow, tell your friends to come and check it out as well. We've got lots of plant emojis for me to share with you in a second. That's great. All right, thanks everybody. Have an awesome afternoon. We'll see you soon. Bye.
Bye.